All right, guys, so which problem? Which problem?
42. So,
Oops.
and I don't know if I'm just plugging in things wrong or what.
42. There we go. Oh, I love it. Okay. All right. The very first sentence in 42. U and V are mutually exclusive. Mutually exclusive. All right. Immediately write down what? Somebody remember what's got to be true.
0.
What's 0? If they're mutually exclusive, what cannot happen? They can't cross, which means there's nothing in both. So the probability of U and V is 0 because it's mutually exclusive. So I said that last time. If they tell you these are independent, take a minute, look at your notes, write down what that means using the symbols they give you. Right? Here, mutually exclusive. Don't skip that by. This is what they're telling you. Then they ask you 3 questions. The first one is that. Sweet. And now the second one says, I'm not going to do the second one for you, but the second one says, what's the probability of U given V? Can you write the formula down?
It's U and
Yeah, so the probability of something given something is the first guy and the second guy divided by what goes on the bottom? The second guy, the given dude. Well, that's easy as all hell, right? Okay, that's enough. And then part C, you set up the formula.
My thought was right. I just wasn't sure.
Okay. Yeah, you're fine. That problem is all about translating from English statement to math statement and then using it.
46.
Okay. Okay, this is beautiful. All right. Let me put this up here so everybody can see what's going on.
But I'm sure it's wrong.
You're making me so happy because there are certain questions, if nobody asks, that tells me nobody's doing the homework. Because they're just like freaky shit. So I'm like, I gotta get a question about this or nobody's looking at it. So you're making me feel a little better. You should turn that on, Jeff. Oh, shit. It's good to know how to say shit in several languages.
Right? Especially German.
I know how to say it in sign language. It's really good to know how to swear in sign language. It gets you through meetings. Oh man, I still have that. There it is. Who locked this thing? Jeez. Being so careful. Alright, who's what? Here, this one. This one, just napping. All right, yeah, so. So this one tells you C is Californians and L is Latino. Let's see how this works. You just don't want to turn it. All right, guys. So this problem gives you symbols. If the problem doesn't, you make them up. And then it has a bunch of shit in there. The very first sentence. 48% of all Californian registered voters prefer life in prison without parole, and that's what the letter C means. So how would I rewrite that first sentence in Mathish? What the hell do you mean, Jeff? 40%.
48.
So that's 0.48. That equals the probability of what?
C.
C. There you go. So that's how we rewrite the first sentence in Mathish. Isn't that better? Among Latino California registered voters, 55% prefer life in prison without parole or the death penalty, blah, blah, blah. 37.6% of all Californians are Latino.
So that's 0.33.
Yeah, so what's the probability of L?
That's 0.37.
Yeah, not 0.55, right?
Yeah.
What the hell's 0.55?
That's 55% out of
the registered
37.6.
voters.
So what's the hidden? All right. Is everybody okay so far? So the very first sentence is directly related to C. The last sentence is directly related to L. The middle sentence is the freaky one. There's a hidden word in that middle sentence. Among Latino California registered voters. So given that, I just gave it away. Given that they are Latino, given that subgroup, so that hidden word is given. That is a given. So what's given? Among Latino California. So given, no. What's given? C or L?
L.
L. I know that it's L. Given that they're Latinos. Among Latinos. Given Latinos. What's the probability that they prefer a life in prison without parole over the death penalty law? Yeah, so that would be C given L is 0.55. Among Latino, given Latino, 55% prefer life in prison. That's what C means. The Californians who prefer life in prison over death penalty. Blah, 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 blah. That is the hardest part of this problem, is translating from what they tell you in English to symbols that I can use in formulas. There's another problem that's got even more shit in it that comes after this. This is a nice little prep for it. Let me stop here for a minute. Okay, I like it. Hopefully so among Latino, California, so given that they're Latino, 55% do what C says. So the probability they feel like this, given that they're Latino, is 55%. Now, I'm ready for questions that they ask me, and the very first thing they ask me is this. The very second thing they ask me is this, and the very third thing they ask me is that. That's nice. So just by reading through the paragraph and rewriting what they tell me in symbols, I answer the first three. 47 is just telling me what this says in words, right? This given this. Well, how do I find probability of, what's AB? 44, 45, 46, 47, you can do 48. Which question did you actually ask me?
Probability of L and C.
Oh, okay, beautiful. What's the formula for this?
Probability
There's two ways to write it. Okay, so you can do the probability of L.
times probability of C given L.
This is a formula we went over last time. I know that I had A's and B's in there. Who gives a shit? L instead of A, C instead of B. Now, you could also write this as probability of C times probability of L given C, but why is this first one better? Do you know the probability of L given C? I don't. But I do know the probability of C given L. And I know the probability of L, so I can figure that out. So you take this dude times this dude to get the probability of L and C. I love it. So it, as almost always, the hard part should be translating from the English they give me into the symbols. Once I got them written in symbols, I just throw them into the formulas for the questions they ask me.
What about 51, which is probability of L or C?
So here I'm going to figure this out. What's the formula for probability of L or C? What's the formula?
Probability of L plus probability of C minus probability of L and C.
Do we know this?
Yes.
Do we know this?
Yes.
Yes. Do you now know this? You will after you do this.
Yeah.
So that you just throw them in there and calculate. Calculate. So they ask you these questions in a certain order for a certain reason, because you calculate something and then you need that for the next thing. So you translate from English to math symbols. Write the formula for what they're asking you. So 48, look up the formula. There it is. There's another way to write it. Which one do I know stuff about? This one. Throw stuff you know, throw it in. So the hard part, again, is translating from English to Mathish. The rest of it's just substituting in for the equations for what they ask you.
I did not translate it, but I did it. So I found out 55% of the L, and then it gave me P of C and L. That's
So
why
what'd you get? You got
I got
0.18.
0.2068, and then I divided by 0.376, and I got 0.55.
Okay, wait a minute. Which one are we looking at?
46.
This.
Yes.
So tell me again how you did it.
I'm gonna show you.
Did you do this?
So, because I couldn't figure out, I didn't translate that, right?
So
I
where'd
was
that
like,
come from?
From here, 55 of the L, which is the whole Latino, California Latino voters, and this vote
Oh,
for
I
that,
see.
and that's how I got it.
But that's actually, that's where you stop. No. All right, so the only time that L and C, or let's see, you were doing,
Because L is
I'm with you.
Latino, right? The Latino, but
Yes,
it's
yes, yes.
also who vote.
I got you. So here, what you did was you wrote this.
Yes,
The problem is you calculated that incorrectly.
I calculated.
The only time you can multiply this
It's not
times
incorrect.
this.
Correctly, because it's the same what it gave me this. You know, when I did the P, L, and C, because it's this times this. So it gave me this number, which is this. See? So this is what
Oh,
you
you
wrote.
did this and then put that
Yes.
there? Okay, sure. That's fine.
Is that
Yeah.
wrong? Because I did
No.
it with another problem.
So you, okay, you're fine. Yeah. You gotta be careful though. I don't know if you got lucky
I don't know.
because people know and means multiply, but what's the only time I could just multiply two probabilities together to get an and? Is if they're independent.
I didn't multiply, I just find out the 55% out of the Latino.
No, so you did multiply.
Uh-huh.
Yeah. Okay. Because, I mean, now look at it this way. Look at it this way, guys. 55% of the Latinos prefer life in prison without parole over the death penalty, right?
Yeah.
And what percentage are Latino? 37.6. So what percentage are Latino and prefer the life life in prison would be 55% of these. Okay, so I don't know if that's how you looked at it. You realize you could just multiply those together. That's fine. But you can't always find an and by just multiplying two numbers together, right? So, for example, one of the biggest mistakes people make is they just take this times this to figure out this. The only time you can just multiply two things together to get the and is if these are independent. Because then this part of the equation would just be P of C. Then you can just multiply those together. So the biggest mistake people make with and is they just multiply the two probabilities involved together. They just go multiply them together. I'm like, how do you know they're independent? You didn't.
Yeah, that's why.
But
I
I'm not
didn't,
sure if
because
you got lucky.
Yeah, no, I knew that
Okay.
it's not correct to multiply both.
Good.
But I had to find out, and that's how I saw.
But now this is the one, but you see now they just told you that directly. Yeah. Okay.
It's a game, word game, so that's hard for me.
What you did was you found this using this.
Yes.
And then work this backwards to figure this out. But you already knew this, and that's why it was a little freaky. Okay. Again, there's another problem later in this homework
Yes, 8.
that has more parts to it. It's really the
And it's
exact
the
same
same.
thing. It's just more stuff. So you got to really first translate everything in the paragraph into symbols. If you do all that correctly, the questions they ask should be very simple. Now, if you don't do that correctly, they're going to suck.
It took me 3 hours, then I have to redo it.
All right, I can't control that. If you're having that much trouble with something, definitely go get some help. Pass that problem by, try some other problems out, get some help with the one that's slowing you down. My purpose here is not to absorb all the time in your life with statistics homework. It's not, believe it or not, that's not my purpose. Right? So if you're like, I've been on this problem for almost an hour now, go, let me let go of this damn problem, do the next one, get some help, come see Jeff before class. Right? Normally you're this far away from understanding and you feel like you're this far away. But you have no idea because you don't understand. You don't understand how close you are. Okay. Anything else from homework stuff? No, okay, all right. Scared everybody into silence. So as always, I'm sure you saw this in your algebra classes and such, there are multiple ways to get to an answer, right? So I love that you just realized it just makes sense with what they told you to multiply those. Of course it just makes sense. It's why the formula makes sense. Yeah, but you kind of like did reverse stuff, yeah. Which is, it works. Okay. So let's review what we did yesterday. I want to add on a few ideas, and then I'm going to give you this little group worksheet to work on. So the main things we did yesterday were, we already had this up here, but what am I doing? This is A. Sorry. Not backwards. So that's an and right there. Okay, so this is what we did last time, right? We actually got this formula from this formula. And we made this formula just by looking at what the hell we did. Just by counting stuff. Okay. Almost the only time I would use these formulas is in a problem like that one we just did, where you only have decimal probability. You don't have people you can count. Then you have to rely on these. If I give you a chart or a bag of poker chips, you're not going to use these formulas, believe it or not. It's actually better if you don't. Can you use them? Hell yes. They'll work like monsters, great. But they just complicate things when you can just count stuff. Okay. I like it. Now what I'm saying is, not that equations always complicate things, but equations have to be general and cover every freaking situation. When I have stuff to count, there's an easier way to do it.
Is that a minus or on the second or okay?
Times, yeah.
As a minus.
Coolness. Okay, so look at this idea of and. And remember, just remind me now. Let's do a real quick little problem that illustrates this. So again, just to fall back to this classic, I got 4 green, 5 blue, and 11 red poker chips. Right? For some reason, I haven't traded them in for money. I'm just keeping them as souvenirs. So if I pick 2 without replacement, what does that mean without replacement? I pick 1 and I throw it away or put it aside, feed it to my little brother, whatever. What's the probability I get a red and then a blue? And, right? So what I do with this is it's sort of like a hangman game. I'm going to have 2 spots. And I multiply because it's and. What's the probability the first one is red?
11 over.
Can't be 11, right? Why can it not be 11?
Grabbing a red.
Because that's bigger than 1, right? The highest any probability be is 1. So it's 11 out of 20. Throw that one away. What's probably the next one's blue now?
5 out of
Still 5 blue.
19.
5 out of 19. I really want you to understand that is exactly this formula. That's the probability of a red one. That's the probability of blue one, given that I already picked a red one. Isn't that what that is? That's the probability of blue, given that I already picked a red one. So the probability of red and blue is the probability of red times the probability of blue, given I picked a red one. That's what that is. So why couldn't I just multiply 11 20ths times 5 20ths? Because they're not independent. I can't just multiply those together. Okay, maybe. Now, I'm not... This was a relatively simple idea, right? We lost a chip, so of course it goes to 19. I'm trying to show you that the formula still is correct. But did I really need that formula to do this? No. Why didn't I need it? I didn't need that. I wrote it afterwards because I got shit to count. That's easy. So what is this here? 1/4? I don't know.
0.55.
Who is it?
0.5. Oh, total it's 0.1448.
Okay. All right. And everybody just says, sounds good. Okay. All right. I like it. Let me see. Oh. Now, look at 5/19. Look at 5 out of 19. That's the probability of blue, given that I picked a red, right? Now, help me out. What is 5 divided by 19?
It was 0.2632.
Now, what's the probability of blue just in general, just by itself? Yes.
Explain how you got 19.
All right, so, all
Yes,
right.
2019.
Yeah, so I picked a red one, and I said do it without replacement. So I pick a red one, I don't put it back in. I flick it away, right? So now how many chips are left? How many total chips? There were 20. I picked the red and I flipped it away. How many are there now? 19. So why is this 11 out of 20? What's the 20 represent? The total chips that could happen. Okay, I flipped that first one away. Now there's 5 blue out of 19 chips because I lost that red chip. Did I take all of the red chips out? I like that you said that because that's a common mistake I see all the time and I really don't understand it. How many chips am I picking? 2. I can't lose 11 chips then, right? I don't pick a red one out and say, all right, all you other reds, screw you guys. No. I picked 1 red. Boop. So how many chips are left? 19. This is what? Why is there 11 out of 20 here? That's the probability that I just did that. So out of the times that I picked that red one, 5 out of 19 times I'll also pick a blue one. Maybe. All right, watch this. So what about this? What if just to finish this up. What's 5 out of 20? That would be the probability of blue, period. Second?
0.25.
Yeah. Would you say, now this could get very different answers. Would you say those are different?
Yes.
Are those very different? Yes, they are. They're like over 1% off from each other. That's actually a decently large difference.
They're not independent.
Yeah, it's not independent. Okay. Now let's just keep this idea for a minute. Okay. All right. Let me do one more example with this. This time I'm going to pick 4 poker chips without replacement. And I want to know the probability that I get a red, and then a blue, and then a blue, and then a green. So how many hangman spots? How many spots am I going to have? 4. Here I had 2 because I got 2 chips.
So you have n between them.
So multiplication between them. Now I cannot just multiply 11 out of 20 times 5 out of 20 times 5 out of 20 times 4 out of 20. That's if I did it with replacement. Then all the probabilities would stay the same every time. But I'm doing it without replacement. I take a chip and I throw them. There you go. So what's probably first one's red? 11 out of 20. I haven't done shit yet, right? Still all 20 chips. So 11 red chips out of 20. Throw that away. Boop. Hit somebody. Sorry.
5 over 19.
Yeah, so now there's 5 blues out of 19. Now I want another blue. I flipped that one. 1 less blue. 1 less chip. 4 out of 18. I'll catch up to you, don't worry. And now I want a green one.
4 over 7.
There's still all 4 greens. I haven't touched any of those green ones in there. But now there's only 17 chips. That's a relatively simple idea, right? When does the top go down? Every damn time because not the top, but the bottom goes down every time because I'm losing chips. But the top only decreases if I've lost that color, right? I had 5 blue chips. Now I've only got 4 blue chips. But at the end, I got all 4 green left. I haven't touched any of those. And then whatever the hell that is. 1, 4. Well, don't make me do it in my head because I'm going to hurt myself. 0.000.
I got 0.0076.
Ooh, I like it. All right. Okay. So I don't care how many chips I pick out. You just put that many spots and fill it in with the appropriate probability. So again, if I would have done this with replacement, this would have been 11, 20, 5, 20, 4, 5, 20 still, 4, 20. Right? Nothing would have changed because I keep putting the chips back in. So with replacement is independent. They don't give a shit. Without replacement, oh God, we lost somebody. The probabilities are going to change. All right, I like it. I like it. Now, how many people are in the United States? Do you guys have any clue? Yeah, like 330 million maybe at this. I remember when it passed 300 million back in, I think it was October 2008. My math, yeah, we're going to keep track of this shit. Right now we're up to 330, 340 million. I don't know. I can Google it, but I'm lazy. So let's say there's 330 million freaking people in America. America. You with me? Yes. So let's say that 10% of them do what? Have DirecTV. I don't know. DirecTV is still a thing, right? I don't know. Let's just say 10% of them still have it. Okay. So how many Americans have that?
10.
How do you do 10% of something? You just move the decimal back once. So if there's 330 million total, how many have DirecTV? 33 million. become a 33. There you go, buddy. I'm going to do this. Let me just show you this. If my population that I'm choosing from is so damn huge. Was this population I was choosing from large? There's a population of 20 chips. Was it large? No. So any change is going to make a really large change in the probabilities, right? Stay with me now. So I had to track those. Every step I took, I had to track how it changed because that's going to affect the answer. They're all going to be off by quite a bit. Okay. But now watch this. If I took 2 people, what's the probability that they both have DirecTV? What's probably the first person has it?
1 over 50.
No. It's probably somebody has DirecTV. Some American has DirecTV. 33 million out of 330 million, right? Let me just warn you going in. We are not going to do this shit this way, but I want to show you why it doesn't matter. You see? So technically, if I picked a different person, I'm not going to pick that same person. What's probably the next person has DirecTV? There's one less person now, right? Well, let's see, no. 32, 999,999 over 329,999,999. All right. Somebody help me out. Count. What's this? I'll do it. 10%. Ah. All right, sorry, because I knew it was different. What's this divided by this? Do it. What's 329,999,999 divided by 329,999,999? Make sure you get all the 9s in there, else you're going to get some really freaky. Oh, shit. Maybe I should do it too. It's going to be 10%, but you'll see. Three, two. Get out of there. 3, 2. 9, 9, 9, 9, 9, 9. 3, 2. 9, 9, 9, 9, 9, 9, 9. Yeah, well, anybody got that? Oh, I think you left out a 9. This will be point 0 9 9 9 9. I don't know. 1, 2, 3, 4, 5, 6, 7, 9 9. Now, what would a human call this? A normal human, not a math geek. A normal human would call this 10%. 9 9 9 9. It's like saying, how old is your daughter? She's 9.99999. She's 10. Shut up. Do you understand? Right? In 3 seconds, she'll be 10. She's 10. Shut up. Do you guys follow what I'm saying? So when the bottom is so flippin' huge, when I take one thing away from it, they stay the same. So don't do this shit. What's the probability that both have it? 10% of 10%. It would be 0.1 times 0.1. I don't have to change the stupid things. Why did I have to do it here? Small population. Why don't I have to do it here? Big ass population. Okay. So what do you get? What's 0.1 times 0.1?
Sorry, 0.0.
Yeah, 0.01. 1 out of 100. And if you do this times this, you will get 0.0999999. I mean, you're going to get this, basically. It's just going to round up to this. Good Lord.
Is 1%.
Yeah, 1%. So, let me do a problem from scratch, the way you should do it. This is the reason why we don't have to worry about doing this when my population is huge. All right. So it's... Second?
Yes, that's huge, but what's your...
Okay. I'm always going to make it extreme. There is a... here's the rule for Huge. Huge. If what you're taking, if the sample you're taking is more than 5% of the population. So here, how many chips did I pick? 4. 4 out of 20 is what is it? I can't think of it. Is 20%. Way bigger than 5% of the population. But when I picked 2 people out of 330 million, that's way below 5%. I don't have to. This is when, now please, dear God, I said this just because you asked a really good question. This is the actual rule. I'm always going to make my problems very clearly small, huge. There's not going to ever be like, oh my God, is it, right? You don't have to check this, but just in case you're curious, this is how we define it. Okay, so if my sample is bigger than 5%, then I have to do that. If it isn't bigger than 5%, then I can just do like we did the 0.1 times the 0.1. So here's an example. Let's say that 17% of all humans are not literate. Meaning they can't read it. So if I pick 3 humans, what's the probability that all of them, or none of them are literate? So how many blank spaces do I want? 3. I got the first person, the next person, the next person. And I want none of them to be literate. So what's probably the first person is not literate? What I told you, right? 17%. Yeah, so 0.17. Now please don't do 17 out of 100 times 16 out of 99. I'm going to say, so there's only 100 humans, really. Just because you have 100 Facebook friends doesn't mean that's the only number of humans. Although, the only people left on Facebook are old people, I mean. So this is going to be, again, 17%. And again, 17%. Because how many people are on the face of the earth? I think it's 8 billion now. Is it? 7 or 8 billion. I remember back in the day it was only 6 billion. And they all did stuff, and now it's 8 billion. So notice this. Does anybody notice this is 0.17 cubed? Why does it make sense? Because I have 3 of these. I mean, it's mathematically, right? That's kind of nice. And then whatever the shit that is, I don't know. What is that?
0.0049.
So very small chance. It makes sense. If only 17% of everybody is not literate, good job, Jeff, I'm included, then having 3 people all not be literate should be a very small chance. Okay, so this is really, really, really beautiful. So another example. And then I'll unleash you on this handout. 11% of Americans left-handed. If I pick 4 Americans, what's the probability that first one is left-handed, last 3 aren't? So this becomes a hangman game. I love to think of it like that. Say again?
Is this a given?
What do you mean?
The last 3?
No. What's the probability the first one is left-handed and the last 3 aren't? So how many spots am I going to have? 4. I got 4 people, 4 Americans. What do I put in the first spot? What's the spot supposed to be?
11.
Left-handed. So it's going to be 0.11. Now what's going to go in these spots? 0.89. 89% that they're not left-handed, right? I didn't say right-handed because some people are ambidextrous. Which is nice for them. That means you can use both hands equally. I give my left hand to be ambidextrous, but
Why?
this piece?
Yes, stay the same like 0.89. Is it with replacement?
No. It's without replacement, totally. But that's the whole reason why I went over the millions earlier. If the bottom is huge, taking one out does not fundamentally change what I'm working with. So is this still 0.89? No. Now it's 0.889999. Okay, that's 0.89. Give me a break. How many people am I picking? Out of how many total people? 330 million. So I can let these stay the same. Thank the gods. Again, if you write 11 out of 100 times 89 out of 99 times, I'm like, there's only 100 people in America. Is that true? This is what that says. No. This is beautiful. I can just work directly with the probability. I don't have to change the bottoms and the tops when I have a very large population I'm working with. 20 poker chips? Oh shit. 5 out of 20, 4 out of 19. 330 million people? Beautiful. Just take the percentage I give you, use it. Why are these 389? Because they aren't left-handed, so that's 89%. And then, so another way to write this is 0.11 to the first, 0.89 cubed. Why is that beautiful? 1 left-hander, 3 not left-handed. I love that shit. And then whatever the hell that is, I don't know. 7207. Man, I was gonna get there. What is it? 0.0.
0775.
All right. Oh my God. Okay, so